Hello friends, in today's question, the distance of center of mass of a solid uniform cone from its vertex is z0, z0. If the radius of the base is r and its height is h, then z0 is equal to. So these are four options. We are going to select one of them. So it is given that there is a cone, solid uniform cone rather. So let us draw a uniform cone. And it is given that the radius is r and its height is given as h. So let us consider this is A and this we have O and this is B. Let be this may B and this is C. So we are supposed to find out the center of mass of the solid from the vertex at a distance z0 from the vertex. So this is the vertex. So we have to find out the center of mass. So in this case, let us consider a disk. Suppose this is a disk which is having a radius small r and its thickness of the disk, a solid disk, and it is given as dy and it is distance y from the point O. Therefore we can say, or rather we can say, we know the formula that center of the mass along y-axis it is given as ycm integration of y and mass dm and divided by integration of dm. So this dm is the mass of this small disk and we are going to integrate with respect to the limits and we are going to get the center of mass along the y-axis. So we consider a small disk of radius r, thickness dy. Therefore, let us suppose this point is D. So let us consider that this triangle here separately. So here we have two triangles. One is AOC and another one is our, let us call this is O prime and this is O prime D. See R, this is capital R and we considered OO prime as Y. Total height is h, so we get this height as h minus y. You can see in triangle AOC and AO prime D, you can say h upon small r, capital R will be equal to h minus y divided by small r, corresponding sides. So from here we can find out small r. So small r will be coming equal to as r into h minus y divided by h. So we found out the radius of the disk with respect to the given parameters, that is r, height as well as y coordinate of this disk which we have considered. So we say if m is the total mass of this you can say solid cone, so mass of the solid cone is given as capital M, and volume of the solid cone, will be given as 1 by 3 pi r square h. So we find out mass per unit volume of the cone. Therefore mass per unit volume of the solid cone will be coming as m divided by its volume, pi r square h. Now we consider a small disk, and let us say the volume of this small disk is dV. The volume of small disk is dV. Therefore we can say dV will be equal to pi r square multiplied by dy, and we already know value of r square. First r, let us call this as equation 1. This is our equation 1. So using equation 1, we get the volume dV is equal to pi, and we get this as r square h minus y whole square and multiply by dy. Therefore the mass of this disk, that is dm, thus mass of the disk, which is given as dm, so we can write the, you can say dm will be equal to mass per unit volume of the cone, which we already found out, mass per unit volume, and multiply by the volume of the disk. So we get dm is equal to mass per unit volume is our 3m divided by pi r square h, and volume of the disk, that is du, is our pi r square divided by h square h minus y whole square dy. Pi r square and pi r square cancels out. Therefore we get this as dm is equal to 3m divided by h cube multiplied by h minus whole square dy, and this is our dm. We already know that center of mass along y-axis, but ycm is equal to integration y dm divided by integration of dm. We substitute value of dm, we get this integration y, this is 3m upon h cube h minus y whole square dy divided by integration of dm. So integration of dm will be nothing but m, so m and m cancels out, so we get this as 3 divided by h cube, and we are left with integration of h minus y whole square and dy. And y varies from 0 to h. Okay, from figure we can see this y varies from 0 to h. So we can put the integration of limits as 0 to h. Now we open it, we get 3 upon h cube, integration 0 to h, we get h square plus y square. Sorry, I missed y here. So this will be y multiplied by h square plus y square minus 2hy into dy. And this can be further written as 3 upon h cube multiplied by y, we get 0 to h y h square plus 0 to h y cube minus 2, this is our 0 to h hy square dy. Now it is simple integration upon h cube, and we are going to get this as h square y square upon 2 plus y4 upon 4 minus 2h y cube upon 3, and limits are from 0 to h. In this case, if we substitute the lower limit, obviously everything will be 0, so we are interested only in the upper limit. So we get YCM is equal to 3 upon h cube. First we get h square multiplied by h square by 2 plus h4 divided by 4 minus, this will be 2 also 2h into h cube divided by 3. Now this will be h4, h4 and h4, taking h4 as common, so this will be 3h cube multiplied by h4, and we are left with 1 by 2 plus 1 by 4 minus 1 by 3. Cube goes with 4, we are only left with, so this we get 3h upon 12, and cancel that, we get h upon 4. So we get y center of mass is equal to h upon 4, but we are supposed to find out the center of mass from the vertex. It means this is our cone, and we are supposed to find out center of mass at a height z0 from the vertex. We know the total height is given as h. So center of mass, we get h upon 4, therefore z0 will be equal to h minus h upon 4. Okay. So this will be approximately our YCM, which is equal to h upon 4. So z0 will be equal to h minus h upon 4. Therefore we get z0 is equal to 4h minus h upon 4, or we can say z0 is equal to 3h upon 4. So this is the center of mass from the vertex. This is the position of center of mass from the vertex, and here option number A is the correct option. See, option A is correct. So this completes the question. Thank you.